I'm going to give you a presentation only for 15 minutes about satellite-based actual evapotranspiration over large scale and complex irrigation scheme in Sudan. The outline of my presentation, introduction, and I will give you a case study, the methodology followed, and also I will present results and will end my presentation with conclusion and recommendations. First, we should focus on NENA region, and we are aware about the shortage of water and the severe conditions that NENA region will face. This will be translated to the water sector, and we should be prepared for this. Increasing water demand is one of the driven by several factors like population growth, rapid urbanization, and agricultural activities. But if you think about agriculture, it consumes around 70% of the total water demand. If we are focusing on irrigation, it will be more, or the percentage of consuming water will be more than 85%. Two countries within NENA region, Egypt and Sudan, would be the perfect case study that we can look for. It has the mega and more complex irrigated projects, and they face many challenges. Both countries actually use around 97% of the irrigated area within the Nile Basin. They have also some of the challenges that face MENA region. Climate change, one of the challenges. Upstream development would reduce the availability of water. Both countries actually relies on the River Nile as a water resource, or the supply for the water resource. Okay, so what would be the problem? If we see the water use efficiency between the two countries, like I would just give you an example comparison between Egypt and Sudan. Egypt, there is Nile Delta, and for Sudan, there are several large-scale irrigation schemes there, one of them called Gezira. If we compare it with others worldwide, you will find that the water use efficiency for Gezira is much less than others. To provide such an information and using the new tools like remote sensing for water management and policymakers, we would like to know exactly how much water demand for this section and how much water should be actual supply for better management. The only problem that we face most of the case studies that we are dealing with is the lack of data. And that's why we always see remote sensing is the awesome solution. If we are talking about actual evapotranspiration, this means that the actual water consumption. But there are many algorithms, many methods using the satellite images and the drones to estimate the actual evapotranspiration. Still, which method is the superior for your case study? That's why this is the objectives of this presentation. It is to evaluate different remote sensing methods over actual evapotranspiration for irrigated areas, and propose a novel monitoring tool based on remote sensing for large-scale irrigation scheme, and proposing also the status of water distribution and water use efficiency. We are talking about Gezira scheme in Sudan. Why we selected this case study? Its area is around 8,000 square kilometers, which is almost the same area of Lebanon, and it is under a single management. The water supply actually via Sinnar Dam, one of the dam, but the storage of water in another dam called Zuceiras Dam. And there are two main irrigation channels which deliver the water to the agricultural areas. It is really very complicated or complex irrigation system there. The main crops within the summer crop season, sorghum, cotton, groundnut, and during the winter, there is wheat. Just to have an idea, the rainy season for the summer crops starts from May, June to October to November. And as you can see, there is a significant amount of rainfall also within the area. First, for the selection of the actual evapotranspiration method, it is well known that energy balance method is a superior method to estimate the actual evapotranspiration, and there are many algorithms and models we can use using the same concept. The one can note that CPAL, which is widely used and validated all over the world, and that's why we selected in this study. Metric, also it has the same foundation of CPAL, but it is a different algorithm. That's why we selected both for energy balance. The problem of the energy balance equations or algorithms, it is really complicated and it takes long time to be applied. That's why we have selected the simplified surface energy balance model. It is a simplified model just to reduce the amount of work for the other models. We also used one of the available products, which is MOD16. It's delivered from MODIS sensor via remote sensing, and it has been validated for many places all over the world, but not yet for Gezira scheme. For the evaluation performance, we are talking about area without any measurements. That's why we have got some of the validation data, which was made by Professor Bashir in Sudan using lazy meter and water balance method to estimate the actual evapotranspiration on farm level. Unfortunately, these data was only in 2004. But we have also introduced other methods how to validate the entire Gezira scheme, like having a water balance for the entire area, and we have collected many data. Also, there are many of the publications produced from this work to propose new methodology to validate the estimates of ET based on the NDVI and the integrated NDVI. And I will show you what I mean. Also, it is not only a comparison, but we have also set a ranking approach based on some of the statistical analysis. We ranked the parameters and to select the right approach to be validated for the scheme. After that, we have also proposed some of the indicators. These indicators used for assessing the water use efficiency over the scheme. As a result, we have compared within the field data and accordingly for the entire scheme for the crop season 2004. And the result actually was very promising for some of the models and not promising for others. As you can see for the distribution and the comparison with the integrated NDVI for seasonal base, it's considered as a new assessment method to be compared. We have made test performing model for each statistical parameter based on the water balance on the field and the NDVI on the field and the integrated NDVI and regional water balance all over the scheme. And we gave the score for each of the methods. As you can see for the score, it was actually for SISIP. The method, the simplified surface energy balance method, was the highest score. And we adopted this model for more simulation. So we used SysIP model to make the simulation over Gzero scheme, starting from 2000 until 2012. As you can see, we cannot use the values without making a validation. That's why we propose a certain criteria, a certain steps to validate what we have estimated. And as you can see here, for the regional water balance for the Gzero scheme, there is a closed number of the ET from the SysIP, which is the remote sensing estimates, and from the water balance. And it varies actually between the summer season and the winter season. The winter season was higher in terms of R square, in terms of regression between the NDVI and the water balance estimates, because of lack of rainfall, because it sometimes bias actually the correlation. Here, this is a spatiotemporal assessment of the Gzero scheme. As you can see, the distribution of the summer crop season in different years, it was enhanced for the distribution, but what we observe, it is always the northern part of the scheme has a dry pixels. During the field visit, we have discovered this. There are many problems with the irrigation channels within the scheme, and the farmers try to use irrigation pump to deliver the water. Also, we can use actual evapotranspiration in a different way. We can get the spatial distribution and the trends rather than the using of the absolute values. And in this case, we have identified water problems for the schemes. We have identified around 80 irrigation channel with water spillover from the irrigation channel in the Gzero scheme. Also, we can utilize the actual evapotranspiration values with the integrated NDVI, and I have published a paper introducing a new index called crop water consumption index, which is the actual evapotranspiration for the agricultural area divided by the total actual evapotranspiration all over the area. And from this index, you can trace and compare the efficiency of the scheme within long period. And as you can see here, this is the water policy for the schemes starting from the implementation in 1925 until 2015. And in 2010, it was a significant change by giving the responsibility to Ministry of Agriculture to manage the water, and that's why there is some of the decreasing in the efficiency, but starting from 2013, it started to be increased. In conclusion, we have introduced some of the new remote sensing-based indicators for irrigation water management, where validation data are extremely difficult to be obtained. A process to evaluate the four methods using water balance and NDVI at the field or at the scheme levels were developed. The assessment of ETA using remote sensing provides information on the existing pattern of water use, and we have identified the potential water shortage in certain locations. Crop water consumption index, one of the successful indices that we have validated when we don't have long-term data, especially for the large-scale agricultural schemes. Of course, we cannot manage what we cannot measure. That's why it is recommended to have some of the validation data for any of the area, even if it is a farm or lazy meter devices. Edcovariance proved it is one of the powerful tools for data validation. Also, it is recommended to continue the research by using and introducing other products and